Okay, so now we're going to look at logarithms with different bases. And one thing that we got to look at before we get into that is the change of base property. This is something you learned a long time ago. It's not new. Log base a of x, we can rewrite into any base we want. Since we know about natural log, we're going to use the natural base e. So natural log of x over natural log of a. We can choose. We could have chose common log. We could have chosen log base 2, but we know how to do calculus with natural log, so we're going to use the e as our base. Once we know that, we can handle um, any base in for derivatives. So let's see here. Derivative of log base a of x. We're going to do the change of base. So we get natural log of x over natural log of a. Let's separate that out just a little bit and make it clear. We have 1 over natural log of a, that's a constant, times natural log of x. So what's the derivative of a constant? Well, itself. What's the derivative of natural log? 1 over x. So you can write this as 1 over x ln a. I like to separate out just to keep it straight in my head when I'm writing it out. So if we look down here, I did write the base 10, even though this is common log, but you can do that either way. This can be any number. So the derivative of log base 10, or common log, of 3x plus 1, I like to write 1 over natural log of 10 right away, and then it's just like doing natural log. So 1 over the inside, 3x plus 1 times the chain rule. Derivative of 3x plus 1 is 3. We can put our constants here and leave our function here if we're going to do more calculus, or we can combine them if needed. But that's all there is to those derivatives. When we get to the integral, if you'll remember, we couldn't do the integral of natural log of x yet. That requires another technique. Same thing here. But we have more options. Because we have the change of base, we can change the base. So we can either do a change of base, where the integral of log base a of x dx equals the integral of log base x of log over log of a dx. So we can change that, see if that does anything for us, or we can let u equal log base a of x. So let's see, let's do both on this integral and see how that works. So just because we see the log in the integral doesn't mean we can't do it. We just can't do the basic form. If it's just the integral of log of x, we can't do that. But if it's in there, we do have options. So first option, change of base. Log base 2 of x becomes natural log of x over natural log of 2 times, now x is still in the denominator, so 1 over x. Well, natural log of x, we said when we see that, that is our u. So u equals natural log of x. Du is 1 over x dx. Now you see why I separated that. This becomes our du. This is our u. And natural log of 2 is a constant. So 1 over natural log of 2 out front. Throw those constants out front. Deal with them later. Natural log of x becomes u. This becomes du. Now we've got an interesting thing, because now when we integrate, it has nothing to do with logarithms or exponents. It is a polynomial. So we get the natural log of 2 in the denominator out here times 1/2 u squared plus c. Well, multiply those together, we get 2 natural log of 2 times natural log of x squared plus c. Okay, not pretty, but that wasn't too bad. Let's look if we just let u equal our logarithm here. So u equals log of base 2 of x du Well, we just learned to take the derivative, right? It's going to be 1 over the natural log of the base times 1 over the inside times the derivative of the inside, which is just 1, dx. Well, let's see here. Let's rewrite our function here. We have log base 2 of x over x dx. Let's see, this is going to become u. 1 over x and dx, and I need a natural log of 2. These become du. Well, I multiplied by the natural log. No, I divided by the natural log of 2. So on the front, I need to multiply by the natural log of 2. That's a lot. So this factor's here on the outside. We have the integral. Our numerator becomes u. Our denominator plus this factor and the dx becomes du. Once again, we have a polynomial instead. So natural log of 2 times 1/2 u squared plus c. We get the natural log of 2 over 2 times log base 2 of x squared plus c. Are those the same? They look a little different. If we change this to natural log of x over natural log of 2 and square it, I think we'll see that they are the same. We get natural log of x squared, that's here. This has the 2 in the bottom, that's fine, but the natural log of 2 in the top here, well, if we look at this factor, there's 2 of them down here from this squared. That's one of them will cancel here, leaving 1 for the denominator. So yes, they are the same. So once again, just because you get a different answer than your friend does not mean that one of you is right and one of you is wrong. It might just be the same thing in a different form. So keep an eye out for that.